Perfect. Welcome, everyone. And we're live. Welcome to yet another workshop of Hunt-A-Thon, the Archway Hackathon. Super excited to be on a workshop role this week. I know this week has been like super heavy, but hopefully, this will help you in building your DApp or building your project that you're doing for your respective hackathons. I'm super excited to bring this as an extension to what we also spoke with Kayansky from Abstract about the CW Orchestrator one. For this one, we have Robin with us from Abstract, and he's going to talk about modular building and testing on Abstract. Just to clarify, this is under the bounty, which is called Archway DApp Expansion Tracks and Bounties, under which Abstract is offering a bounty of 5,000 USD. But Robin, before we dive into the content that you have for the devs today, would you maybe like to reflect on the bounty or maybe talk a little about what you are expecting out of the hackathon?
Yeah, sure. Thanks for the introduction. So for the bounty, what we're really looking for is, first of all, anyone that is building an application with Cosmosm to use our tooling. So Kansky came on last week to talk about CW Orchestrator. It's a tool that we developed internally because we actually really needed it to be very productive in our code base. And we think it is a very valuable tool for any developer who is writing Cosmosm smart contracts because it allows them to test it easily, to deploy it easily, to do it on any network or any environment. So it's really very powerful. So if you are building your code and you use Orchestrator, then you're eligible for some of the bounty money. And then in addition to that, if you build your application on top of Abstract, you learn how to use Abstract, you come onto our Discord, ask questions, we can help you as well in actually building it out. Then there's some additional bounty that you could get from us.
Perfect. Yeah, I think now is a good time to get started on the content. But before that, if anyone watching today has any questions during the course of the workshop, feel free to drop it in the chat and we'll take it all up towards the end of it. Yeah, Robin, on to you now.
Amazing, thank you. So as already mentioned, today I'm gonna be presenting this little workshop on building a dollar cost averaging app. So from a high level point of view, we're going to be using the Abstract platform to do this. And Abstract really consists of three different components. We have the dev tooling that Kiansky already showed off last week. There is a really good recording of it available on our YouTube channel. So if you haven't seen it already, or you don't know what CW Orchestrator is, then you should definitely go to our YouTube channel, go watch that video. Then this DCA workshop is going to be on the on-chain infrastructure. So these are the smart contracts that Abstract we deploy to the Archway network, and that you can then use to build your application on top of, to distribute your software as the infrastructure, with the infrastructure we provide, as well as the SDK, which is something that we'll dive into in this workshop. Now we also have some front-end libraries that make it easy for you to interact with your application once you've deployed it to the infrastructure, and actually make a really nice front end for it so that you can publish it and other people can use your app. So what is dollar cost averaging? What are we actually trying to build here? So dollar cost averaging is an investment strategy that tries to reduce the investment risk by spreading the purchase of your asset over time. So instead of buying one huge bag of Doge on Monday, you spread it over the whole month, and that way you can reduce the volatility and get the average price of Doge instead of buying it maybe at the top. If you're lucky, you would buy it at the bottom, but you don't know, right? So this way you can spread your purchase over time. And there's already a project within Cosmos that does this. It's called Calculated Finance. They have a really nice UI. They have a lot of additional features where you can set up the dollar cost averaging to buy more or less depending on the price of the asset. So if you kind of want to have some inspiration on how you can extend this further, then I would definitely recommend going to their webpage, learning about them, and actually using their product, because it's a good product. So functionality wise, in our application, if we want to start implementing this, we need to have 3 major functions available. The first one is to be able to instantiate the application and to deposit into it. So when I want to start dollar cost averaging, I will create a smart contract, I will configure it, I will tell it, hey, I want to buy Doge every day of this week, and I want to buy $100 worth of it. So you should be able to do that, and then also provide the funds. The second step is to have the buying be automated. So there needs to be something that triggers the smart contract to do the swap for you once a day. And this is something that the application also needs to do. And then we should also be able to withdraw the funds, which is quite natural. So what are some of the requirements for this application? We need to be able to do swaps, right? So we need to interact with a decentralized exchange, like Astrovault, like Osmosis, really any exchange that's available. And how we do that through code is we need to know the message structure of the messages that we need to send to these contracts, as well as the addresses of these contracts. So we have to go look in the code, etc., etc. Then for automation, we really have 2 options. We can either write our own bot. So we can use CW Orchestrator that will run a cron job. We provide it with a wallet with some funds, and then it will automate the execution of the DCA. Alternatively, we could use an external service. There are some services out there that allow you to just give it some funds and tell it, hey, I want you to execute this contract based on these rules. And then the question is, how do you set that up? So, this little application, the DCA application, we already have a bit of complexity, because now we have to work with the exchanges. We have to find out how to automate it. It's already, getting a little bit more than what we expected it to be. So let's start with the DEX integrations, right? So let's say I want to do a swap on Astrovault. I have to go look at the source code of Astrovault. I have to import their packages. I have to write calls to their contract. Sometimes that's not very intuitive. Sometimes you have arguments in the calls that aren't very self-explanatory, or that maybe if you format the call incorrectly, then you get an error and you have to debug it. And testing it is oftentimes very hard, because sometimes the source code is not available. And if it is available, then you need to instantiate their contracts in your own tests and then interact with them. So there's really a lot of work that goes into integrating with an exchange. And that's like one exchange. Let's say you wanted this DEX or this DCA application to be agnostic to what exchange it uses. Then you're in for a very rough time, because you have to integrate with every single exchange and make it work and test it and keep it maintained, etc., etc. So that's really hard, and everyone who is doing swaps or providing liquidity, etc., in their applications, they're doing this from scratch. So everyone is kind of just grinding away at this, and it's very inefficient. So what Abstract aims to do and aims to realize is to acknowledge that we can actually separate the integration with the exchanges from the application logic, right? This can be 2 different contracts. So how does that work? The solution is this abstract framework. And the way that it works is you're able to create, the abstract framework enables you to create accounts. And accounts can be used to create composable applications. And these composable applications use software that is published to our platform. So an application that is built on top of Abstract is really some smart contract that is installed on top of an Abstract account. And this Abstract account can hold funds and can execute messages. So that sounds a little bit, might sound a little bit unclear, but I'm sure it'll make more sense later in this talk. So it's modular. So as I previously said, the smart contract wallet is extensible. So when you create an abstract account, you create a smart contract that can hold funds, and that's basically all it does. And it can execute messages. When you install a module or an application, what you're doing is you're giving this module permissions to execute messages on behalf of your account. So that way you can customize the creation of actions in your module and then forward them to the smart contract wallet, i.e. the abstract account, for them to be executed. And you can then compose these modules on top of each other to create very like dependency-based architectures. So how would that work? One of the things that we made is this DAX adapter. So I mentioned previously that it's really hard to integrate with exchanges. It takes a lot of time. You need to properly test them. You need to maintain them, etc., etc. What if there was a contract out there that already did all of that for you, and that has one single API that is very easy to understand, that is very easy to use, and you don't have to care about any of the intricacies of the exchange? So we actually created that smart contract, and it's called a DEX adapter, and it exposes a standard API to interact with DEXs. So this enum that you see is a little snippet of the API that we expect in this DEX adapter when you call it. And one of the variants is swap. And in the swap, you tell it what the offer asset is. So in this case, it could be USDC, as well as the amount, so like 100 USDC. You ask it for an asset, so you say Doge, I want Doge, and then you give it some optional parameters to assert that the swap doesn't have too much slippage. And above this, there is a specifier which specifies which exchange you want to use. So that could be Astrovault, for example, or Osmosis, etc. So, and once you have given this message to the DEX adapter, right? So this is an example. You, as the owner of the account, can call the DEX adapter contract, and you can say, "Hey, can you do the swap on Osmosis and dollars for euros, blah 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 blah." The DEX adapter contract will be loaded, it will be executed, and it will understand that you're trying to swap on Osmosis because that's the exchange that you requested. It will figure out which pools you want to interact with based on the assets that you provided. So if you say euro and US dollar, it will search in the memory of the contract, and it will find out that it's pool number 25, and that the actual assets that you need are certain addresses, etc. It will take all of that information, put it in the correct message, which is shown here on the left, which is completely unreadable, right? So if you get this message as a user in your wallet and you want to sign it, it's like, what am I doing? Previously, this is actually if you're calling this contract, this is the message that you will be signing in your wallet. So you can actually read the message and be, okay, I'm going to do a swap on my account. This makes sense. So once that's generated, the DEX adapter then forwards it to the abstract account where you have your funds, and it gets executed, and the swap is performed. And the cool thing is that this is extensible. So instead of you calling this DEX adapter, it could be another contract that will call the DEX adapter that will request to do a swap, and then the swap will be performed. So now your application doesn't have to care about the implementation of the exchange anymore. You can just call the DEX adapter, call it from your own smart contracts with a unified API that is very easy to use and understand. So for this DCA app, we're going to be using two dependencies. First of which is the Croncat dependency. So the Croncat application is something that we built in-house, and it interacts with Croncat infrastructure. Croncat, if you don't know what it is, it's a way to do cron jobs on chain, and it's very cheap and it's very easy to use. So we'll get hands-on with that in the workshop. And then the DEX adapter is the other one we actually want to do swaps. So we need to be able to delegate those calls to our DEX adapters so that we can do the swaps on the exchanges. We also have other integrations. So we have a lending market adapter that interacts with Mars protocol, which other ones? And some other ones that don't come to mind right now. But you can do, so you can lend, you can provide liquidity there, get some yield. We have DEX adapters, so these do swaps, but also provide liquidity, withdraw liquidity, etc. We have the Concat app, and then we have some other applications like subscription app, so you can set up subscriptions for certain contracts. You can request a hook for when the user stops paying his subscription. So you can actually have functionality in your contract where you require someone to pay for it over time, and if they stop paying it, you can disable the functionality of the smart contract, which is really powerful. We have this ETF application, the payment app, etc. So we have a lot of libraries. You can go onto our GitHub and kind of peruse in our smart contracts to figure out more. So now I want to get started with the workshop, get hands-on. So I'm just going to put some links in the chat right now that you can use to get around. I'm not sure if it's being posted. And I'm also going to share my screen if I can. So, time screen. Okay. So this is the webpage for the workshop. If you go to GitHub, Abstract SDK, and then DCA module workshop, you should be able to find the relevant repository. And oh, okay, cool. We'll do this. So you should be able to go to this repository, clone it locally, and then we can get started. So the idea of this workshop is that we have some quests in this DCA contract that need to be fulfilled. So we'll go through each quest. Each quest is encapsulates some ideas, some concepts, some code that I want to explain about Abstract, and then you can fulfill the quest and learn about how to use the framework. So there are two branches on here. The first one is quests, that's default, and then there's a solution branch. So the quests has the unfulfilled quests, and the solution one has all the solutions filled in. So if you're working on a specific quest and you don't know how to complete it, and you're really, out of energy, then you can go to the solutions branch and have a sneak peek at the solution. So you can click use a template, create a new repository, and then go from there. I also linked some, there are some links in the chat right now that link to our webpage, to our documentation on CAB Orchestrator, which is a tool that we will be using extensively as well in this workshop, as well as some documentation, actually a lot of documentation on Abstract itself. The first part of the documentation is geared towards conceptually explaining some of the concepts that we apply in the framework. And the second part of it is building with Abstract. It guides you through more of the code, how to use the code, how to interpret the code, and some of the packages that we have available to make your life easier. So with that out of the way, if there are any questions, feel free to put them in the chat. Okay. So the first thing we do is we go to Quest 0. And Quest 0 is all about module dependencies. So remember how we wanted to use this DEX adapter and this the Chromcat app to be able to set up automation and to do swaps. The way that you can do that and tell the abstract platform that you want to depend on these applications is to use dependencies. So if we go to Quest 0, we can see here that we have our abstract DCA app. And the DCA app is comprised of this constant that we will discuss later. We have a kind of a builder pattern that you can use to create your application. So you give it the type of your app, which is an app contract. You call the new function on it, and then you give it the ID. The DCA app ID is a unique identifier that the framework uses to figure out what your application is. So you can see it kind of like a crate name or a package name, something similar. Now it has two components to it. The first one is the abstract name before the colon. The abstract name is a namespace. So we publish all our modules and our code under the abstract namespace. You will probably want this to be something different. So you can make this like my namespace or whatever. It needs to be unique. So if it's already claimed, then you won't be able to publish your module. And then this other part is actually the identifier of your package or your contract. So in this case, it's DCA or like DCA workshop, whatever. Cool. So that's the ID. Then the version is also really important. We just use the cargo package version here. And this will ensure that when we compile the contract, when we load it on chain, the version will be stored on chain as well. And that way, other contracts can also know what the version of this contract is. Then if we go down, we can add these handlers, which I'll talk about later. And we can also add dependencies. So we already have the Chromcat dependency in here. The other dependency that we need is the DEX adapter dependency. So to do that, we can add a static dependency. We can say new, and then we can give it the DEX adapter ID. So this DEX adapter is a crate that we imported in our cargo.toml. We're depending on this, the abstract DEX adapter. And it has an ID, and it also has a version. For the version requirements, you can give it any string. You can also give it constraints. So you can say it needs to be bigger than a certain version, smaller, etc. And all of these constraints will be asserted on chain. So when you install your application, you say which components of the application you want. And if these version requirements don't check out, then your transaction will fail. So it's actually impossible to create an application that depends on versions of smart contracts that are incompatible with the code that you're using in your own source code. So that is really, really nice. It's like an on-chain package manager, basically. So in this case, this is available under DEX adapter contract version. Amazing. So now when we compile this and when we instantiate it, it will be asserted that we do have this DEX adapter installed on the account and that it respects the version requirement. Sweet. So let's continue to Quest 1. So Quest 1 is admin validation. So every application that is installed on an account needs to have an admin, and it already has an admin. The admin is always the owner of the account. So when you go to our platform, when you create an account with your wallet, then your wallet will be the admin of the account. And that way, if you have any permissioned code that you need to make sure that only the admin can call, you can use this admin that's already included. So in our case, if we go in here, update config, we might want to change the asset that is used to DCA into the to buy the asset, or we want to change how often it happens, etc., etc. We don't want anyone to be able to call that. We only want the owner of the application to be able to call that. So the way that we can do that is we can take our app object and then get the admin and then assert the admin with our deps, and this is probably dot ref, and then the message info center. Sweet. So now we have asserted that the caller is actually the admin of the account and of the app. So that's very nice. If you go to 2, we have the composable APIs. So before we go to 2, I just want to explain this weird type that we have up here. So update config is a function that is called in our execute handler. So if you're a little bit familiar with Cosmosm, you should know what the execute function is. The execute function is a function that is called whenever your contract is executed, and it can make changes to the state of the contract. So usually you have these available, right? So you have the dependencies, environment info, and the actual message that is executing a contract. With abstract, you have this app object available as well, and the app object encapsulates your application. It encapsulates your smart contract. And the reason why we have this available here is because this object includes some state about the abstract infrastructure that it can use to provide some functionality, and yeah, we'll see that in the next quest. But just know that we insert this application struct in your handler, and it's really powerful, and it really enables you to work with the framework and do some really powerful things. So let's go to 2.0. So right now we have to pass on a message to the Croncat API. So if you go up here, create DCA. So we're trying to create a dollar cost averaging strategy on the application. Only the admin should do this. We load the configuration, okay, and then we want to validate that a swap can be performed between 2 assets. So we provided with some assets we want to swap, but how do we ensure that this configuration that we're trying to add can actually be executed? The way we can do that is by simulating a swap. If the simulation fails, then we know that whatever request the user is making, it won't work because there's no way to swap. And if it succeeds, then we know that the execution will work. So the way that we can do this is with something that we call APIs. So APIs are objects that you can retrieve from your application that enable you to do more complex interactions with other smart contracts. So in this case, we already set up the dependency on the DEX adapter, and we now want to call this DEX adapter to do a simulation of a swap. And to do that, we can take our app object. We can then get the DEX interface or the DEX API, and we do that by giving it the dependencies as ref and then the name of the DEX. So I'll just Astrovault. I think this is actually in the config that we load, so I can do config dot DEX exchange. No, maybe that's up here. DEX name. Oh yeah. Cool. So now we have this this API object, this DEX object, And if we click into this code, this is actually exported by the DEX adapter dependency that we have. So you can include APIs in your own module, for your own module, so that other people can use your module as a dependency and then easily interact with it through the API. So we have .dex, and then we can do simulate swap, and then we can give it the source assets, the target assets, and the pool. Okay, actually, this is a little bit of a nuance. There are two dexes. There's the normal dex and the ANS dex. The ANS dex uses something that's called the abstract name service, and you can go into our documentation to learn more about that. It enables us to do the chain abstraction. So instead of having the addresses for assets from another chain locally, we use a denomination and we resolve that denomination on the chain locally. So it's like DNS, but then for smart contracts. And in this case, that's what we're going to be using. So we have our offer assets, our ask assets, and then I don't think we need anything else. No, that's it. And then we unwrap that, and if it fails, it will error, and it will. But then we know that the configuration is bad. So that's great. We also need to clone those. Sweet. So now that is set up. Then we can go to Quest 2.0, and this is for Croncat API. So once we have this this swap done, we can create an entry, we can save it so that we can have different strategies at the same time. And then the last step is enabling automation for this strategy. So we need to call Croncat to tell Croncat to periodically call our contract to do the swap. So the way that we do that is we do app.croncat. Again, Croncat is an API that is exposed in the Croncat module, by the Croncat module. So it provides some helper functions to easily set up cron jobs. And then we do deps.asref. And then we can create a task. And I don't quite remember. I don't quite remember the source code that we need here, but you can do it. Croncat task requests, interval, boundaries, stop and fail, etc. So this is something that you can dig into a little bit more. If you're doing this at home, you can figure out how Croncat works a little bit. It's really not that hard to use. And then once this message is set up, you actually get a message back, a Cosmos message, and then we add that to our response. Add message. Sweet. So then our contract will call the Croncat application, and it will request to set up a cron job. Then these other requests are very similar to the ones that we just did. So I'm gonna skip over them. Feel free to do them. You can also look at the solutions branch if you're curious to the solution. So if there are any questions about these APIs and the abstract SDK, feel free to drop them in the chat. There's also the create documentation about the create itself on create.io that I will share. That will be shared in the chat. Second. And the abstract SDK create is really where most of the APIs that we also built in-house are exposed. So you can do balance transfers, token transfers from your account to other accounts. You can do things with OddZ. You can do things with fee grant. You can do things with really anything that involves programming a wallet or an account. So next quest is the module message types. So as previously, like in the beginning of the workshop, I showed you this beast of a constructor, and I kind of skipped this type. So this type is actually really important because it defines the API of your contract. If we look at what this type is, it has a lot of generics. So we have a custom error type, we have a custom instantiate type that we can provide, execute, query, migrate, etc. And this can be provided in our type to create a type alias that will define our own application. Right now, our instantiate message is set to empty. And that's not really what we want, because we want to be able to configure the application when we deploy it. So we can do a DCA instantiate message. Instantiate message. Okay, I'm gonna have to check. Okay, it's called app instantiate message. That's a little bit unfortunate. Can put that in here. And then you're gonna notice that this gives us an error. And the reason is because now our instantiate handler, our message is not empty anymore. This needs to be our app instantiate message. We need to import this. And now we can actually fix these things. So you can do a query to ANS to resolve to the asset, etc. So if you go to our documentation and read up on that a little bit, you should be able to also figure that out. Cool. And then we have this setup. If we go to our actual message struct on top here, and there's also this boilerplate that is here, and that is actually defining the top level messages that our contracts expect. So every module is just a causal module smart contract, with the difference being that it has an API that already has some implementation to it. So, for example, this our DCA app is an abstract app, and it has an instantiate message that is already partially provided. So I think I can find that in here. If you go to messages, no, not in here. If I go to base, oh, this is yeah. You don't really have to know about this too much. You just need to know that the top level messages are exposed in a different way. So instead of having all this boilerplate, we have a really nice macro that you can just insert in here. So you can just do app message types and then provide the type of your application. So if we look at this, it's my app and then execute and query. So it is DCA app, DCA execute, and DCA query. This should work. Yeah, define multiple times. Sweet. Cool. And again, you don't really need to know about these because our tooling abstracts them away from you. Cool. So that was quest 3. Then we can proceed to quest 4. Cool. So quest 4, if you go to a README, is about the testing setup. So now you should be able to implement some functionality. You should be able to use the APIs through our abstract SDK. You should be able to customize the API of your contracts to implement different logic, etc., etc. But in the next step, once you've done all that, how do you actually go about testing your application? So to do that, we make use of CW Orchestrator. Again, if you don't know what it is, you go to our YouTube channel, Abstract Money. There's a really good workshop that happened together with this hackathon last week, and it shows you how to use it. So this is the setup that we do for the test. So we have the setup function that we use in the beginning of the test. We use CW orchestrators to set up a mock environment. We add some balances to different people in the test. We then set up the concat contracts. So this is a little bit manual because Croncat is an external project. So we had to go and figure out how to do that, but we did it anyway. So the beautiful thing is, if everyone uses CW orchestrator, then this should be very easy. So, for example, for Windex, we did the CW orchestrator integration ourselves. And as a user, if I want to, or as a developer, if I want to use Windex in my test, the only thing I need to do is Windex deploy on and give it my test environment, and then some optional deployment data, which in case of Windex is empty. Then the brunt of our testing infrastructure, the abstract testing infrastructure, revolves around our abstract client. So the abstract client is a builder that you can provide an environment to. You can provide some information for ANS, the abstract name service, which are assets, contracts, etc. You can learn more about that in documentation. And then once you build it, the abstract infrastructure is deployed to the environment, to this testing environment, and you get a client in return. And that you can use this client to now create accounts, to publish modules, to do anything related to abstract infrastructure. So after also deploying Windex, we want to create a publisher. So a publisher is an abstract account that publishes code to the platform. So to do that, we call the abstract client, we take a publisher builder, we give it a namespace. So as I previously said, the namespace is the beginning part of the ID. So that would be abstract in this case. And this builder will try to either retrieve or create an account and claim the namespace for this module. So in this case, it's a test thing, so it will create a new account and claim the abstract namespace. Then we need to publish our adapter because that's the dependency of our app. We can just do on the same publisher because it owns the same namespace. We can say publish adapter. We can give it the instantiate message of the exchange and it will publish it to abstract. Then we need to do the same for a Croncat dependency. So we do abstract client, publisher builder, do the Croncat ID. We have to do a new publisher because Croncat is a different namespace. So it's also a different publisher. And then we publish it. Very easy. And now we have to publish our own application. So in our case, currently our namespace is still abstract. So we could have reused the old abstract publisher, but if you're working with a new namespace, you have to customize this. Then you need to create a new publisher and then publish the namespace under here. So you can do DCA publisher.publish app, and then do that. And this publish app will upload the code, register it to our infrastructure, etc. Then down here, we want to actually install the app. So we can create an account by using the abstract client, an account builder instead of a publisher builder, and then install an app with dependencies because we have 2 dependencies in our application. And then we provided the instantiate message we provided an optional config for the dependencies. In this case, we don't need to configure them. And then after we build the application or build the account, we have everything installed on there, etc. I see that there's a question in the chat. If we have a new version of the app, does the account automatically use the latest version? No. So you can upgrade the version of your app that is installed on the account through our front end or through a script. And yeah, that basically prevents someone from migrating contracts. So this might be a little bit out of scope, but we recently did a thread on MiFi, and the idea here is that instead of having one deployment of a smart contract and that being managed and owned by the developers of that code, you let users create their own instances of these abstract apps and manage their own applications. So it's like having your phone and installing an application on your phone, and then on the App Store, you can upgrade it and you can get the latest version. But you only do that if you want the newest features or if you trust the developers, etc. So that doesn't happen automatically. We are working on a way to optionally enable automatic upgrades, but that is something that is on the roadmap and that we don't have yet. Also, when you upgrade an app, let's say that another module depends on your application and you're trying to upgrade your app to a new version, then if this new version is not compatible with the version requirements of the module that depends on it, then that migration will fail. So we've created this like fault-proof system where you're not able to migrate applications as long as other things depend on it, because otherwise you could very easily break your application if you have multiple modules depending on each other. Cool. So yeah, that is that is kind of just. I hope that answered that question. So if you're interested in actually seeing some tests, here's, for example, the successful install. We have this setup that we do some queries, etc. Do know also that there are really nice helpers available through CW Orchestrator. So for example, here we have our apps. We have our DCA app that we installed during the setup. And then we have this function, module data. And this module data is a query that returns a module data response. But if we click on this function, it actually goes to the type. We haven't written this function ourselves. It is generated by CW Orchestrator through some derived magic. So go to the CW Orchestrator documentation to kind of learn about that. But we really love this feature because it makes the tests and the scripts so verbose. Like we just do DCA app dot module data and we get the query. It's really an amazing feature. Sweet. So the next quest is quest number 5. I have about 10 minutes left, so gonna try to be quick on this one. Now, right, in order to speed up, so this is more about Orchestrator. If I go to the quests, we can create, we can call create DCA on our app. So we can do DCA app.create DCA, and this uses the same principle. So this function is generated based on the message. So we can easily do calls here. And then same here, we can also call DCA to like actually do the dollar cost averaging of the position. So that's quite simple. And then for 6, we can publish to the abstract platform. So this one I'm gonna try to actually perform on the testnet. So I'm gonna remove the changes that I did on this branch, go to the solutions, and then go to the DCA, examples deploy. So to use CW Orchestrator, you need to have, if you want to interact with an actual network, you need to have the a mnemonic available for it, so a wallet, and you configure that in the .env file. I'm not going to show it to you because it's a secret, but you can go to the orchestrator documentation and you can see which things that you need in there, or you can just set them in your console manually so that they're available. The script is going to load the .env file, is going to set up a logger, and then it's going to set up a daemon. So connect the daemon, connect to a network. So that's a Constantine 3 network. That's a testnet. We're going to create our namespace. We're going to get our client. So now notice that we don't have our builder, but we have just a new function. That is because we already deployed our infrastructure to the testnet, so we don't need to build it. We just need to retrieve it. And we give it a network, and through CW Orchestrator, it knows what the addresses are of the infrastructure that we deployed to the testnet. So we have all of abstracts in this little object available for use. Then with the client, we can do this publish for builder, and then we can go ahead and publish the application. So in this case, it's not going to work because, as I said, it's going to use the abstract namespace, and I'm not using that mnemonic. I don't want to publish to abstract. So I'm just going to make a really tiny change here. I'm going to make this Cyber Howard, because that's my pseudonym. And then I'm going to build a WASM. /build release. So this is going to build the new artifact in the artifacts directory. So it's just going to wait for that. In the meantime, I can show you this interface. So this interface is a CW Orchestrator interface that is generated with this little macro. You can go in here and actually see what is generated from it. So if you're wondering, if I do .app.publish, what is actually happening? Well, it is going to search for the WASM file based on your crate. So I will be in DCA, and it will search for the artifacts directory that is on top, and then it will search for the artifact in here that is the same, or like the name contains the name of the package, so DCA app, and it will find that WASM out and it will upload it, and it will kind of do the same. If you're using a mock environment, it will use a wrapper. So you'll be familiar with this wrapper, contract wrapper, that is exposed with CW multitest to get the source code of the app. So now to actually run this, I will do cargo run example deploy, and let's hope that this works. Okay. So we're uploading. Oh, it's not meant to do that. Oh. App successfully deployed. Let's go. Yeah, what happened here is we uploaded it. The logging is set to debug, which is why there's a lot of information here. We executed the version control to propose the module, which is our application. And then we waited for that to be included. And then, the execution was done, and it gives us the results. So we deployed our application to abstract testnet with very little code, right? So it's very simple to do. This was it, I think, for this workshop. If you have more questions, or if you want to get started with a template that is not this workshop, you can also find that in our GitHub. And if you have any questions, feel free to put them in the chat right now so that I can answer them. I would love to answer some questions. And if not, or if you have to dig into it a little bit more before you have questions, feel free to do so and come to our Discord server. We're very happy to entertain a call with you if you have a specific application that you're thinking of building. We also have a lot of interchain logic, so we make it very easy for you to build interchain applications that interact with smart contracts that are deployed on different networks, which can be really powerful. We also have a lot of tooling to make that easy. So really anything dev related, you should talk to us. So yeah. Can show the app template. Cool. So this is the app template that you can use. You can click create a new repository, and then you can easily get started with it. There are some tests in there already. There's a bunch of helpers that help you publish things, etc. So yeah, thank you for joining this workshop, and I hope to see you on our Discord.
Yeah, thanks a lot for that, Robin. We've also put the Discord link in the live stream chat. So just in case if you have questions for later on, and if you want to hop onto the Discord, discuss, ask, or meet other devs, feel free to do so. But yeah, again, like always, I wish everyone very good luck, whoever is building for this hackathon. And yeah, Robin, once a lot. Thank you so much, and take care, everyone. Good luck.
Yes, thank you for having us. Bye.